Medical innovation in the treatment of type 1 diabetes takes a huge leap forward with the invention and trial of an artificial pancreas. Could this algorithm-based smartphone device change diabetics' lives for the better? According to the Centers for Disease Control and Prevention, CDC, almost 1 in 10 Americans has diabetes. Of these, roughly 5% are type 1 diabetics, which equates to 1.5 million Americans. Treatment for type 1 diabetes is highly effective but is a relatively troublesome ordeal. Patients are required to regularly draw blood, check glucose levels and inject the appropriate amount of insulin. Current interventions leave unwanted opportunity for human error. They are also fairly unpleasant and inconvenient. The hunt for better treatments is ongoing. One such improvement showing a great deal of promise is the so-called artificial pancreas. The idea of an artificial pancreas has been discussed for decades, but it is only very recently that it has become a potentially viable option. Designed by Boris Kovachev and his team at the University of Virginia School of Medicine, this medical innovation has the potential to change millions of lives for the better. Kovachev has been working on such a device since 2006. Initially, this type of closed-loop system that could monitor glucose levels and administer insulin appropriately was believed to be impossible. The idea of an artificial pancreas was met with skepticism from the scientific community but, thankfully, Kovachev continued unabated. We show that it's not only possible, but it can run on a smartphone. What is type 1 diabetes? Insulin normally facilitates the absorption of glucose from the blood into the body where it is used. Type 1 diabetes occurs when the pancreas stops making enough insulin. Type 2 diabetes is most often caused by lifestyle choices, such as poor diet and lack of exercise. Type 1 diabetes, however, is unrelated to lifestyle. The beta cells within the pancreas that manufacture insulin are attacked by an inappropriate immune system response, rendering them insufficient for the body's needs. To make up for this shortfall in biochemistry, patients must frequently prick their fingers, take a blood sample, measure glucose levels and inject themselves with insulin to redress the balance. This regular rigmarole is necessary to keep blood glucose levels within a healthy range. Aside from the inconvenience and discomfort, as with anything that is reliant on human interaction, there is the possibility of error. Raised glucose levels can, over time, damage the kidneys, nerves, eyes and blood vessels. At the other end of the spectrum, low glucose, or hypos can, in extreme circumstances, lead to coma or death. Anything to remove the possibility of user error will be of obvious benefit. How the artificial pancreas works. Kovachev's artificial pancreas, also referred to as closed-loop control of blood glucose in diabetes, takes away much of the human interaction that is currently necessary in self-medication. The central hub of the system uses a platform called InControl that runs on a reconfigured smartphone. This handheld device is linked wirelessly to a blood sugar monitor, an insulin pump and a remote monitoring site. The blood sugar monitor takes the glucose levels in the blood every 5 minutes and delivers the readings to the InControl device. The device is controlled by algorithms and administers the correct amount of insulin through a fine needle without the patient having to spill even a drop of blood. The algorithms are where the real innovation comes in. They are designed to second-guess how much insulin is likely to be needed. It is not enough for the technology to simply react to blood levels at any particular moment in time. It must predict glucose spikes, preempt changes and adapt to an individual's insulin sensitivity. This is no mean feat. The human pancreas is able to make these calculations with ease, but to design something as capable as the pancreas is a difficult task indeed. When asked about the algorithms, Kovachev told, "The algorithms are based on a model of the human metabolic system which uses data from continuous glucose monitoring, past insulin delivery and, possibly, other available signals, to recognize patterns of blood sugar fluctuations and predict where the blood sugar of the patient is heading. Then the algorithm delivers insulin based on predicted glucose values." Special attention is paid to the prediction and mitigation of hypoglycemia. A separate algorithm, we call it Safety Supervision System, is specifically tuned for that, and it is quite good at this task. He told us the safety system is their most tested algorithm, It has been in use for many years. Trialing the groundbreaking organ. The National Institute of Diabetes and Digestive and Kidney Diseases are supporting this vital research to the tune of $12.6 million. The artificial pancreas has begun its final trials in 9 locations across the U.S. and Europe. For the first phase, 240 patients with type 1 diabetes will trial the system for 6 months. The second run of trials will see 180 patients from the first phase wearing the system for a further 6 months. Designed in conjunction with Type 0 Technologies in Charlottesville, Virginia, the system will be compared with a standard insulin pump against 2 major criteria: how well blood sugar levels are managed and whether the risk of hypoglycemia or low blood sugar is reduced. Kovachev explains his aims for the artificial pancreas. To be ultimately successful as an optimal treatment for diabetes, the artificial pancreas needs to prove its safety and efficacy in long-term pivotal trials in the patient's natural environment. Our foremost goal is to establish a new diabetes treatment paradigm. The artificial pancreas is not a single-function device, it is an adaptable, wearable network surrounding the patient in a digital treatment ecosystem. Further improvements on the horizon. This innovation looks set to make a huge and positive difference to millions of people. It aims to improve the lives of type 1 diabetics by easing the burden of controlling insulin levels manually. Additionally, thanks to the algorithms, the artificial pancreas should keep blood glucose at more physiologically normal levels. Of course, every medical advance brings with it a new set of horizons to aim for. MNY asked Kovachev whether there are any adaptations or improvements he would like to make to the artificial pancreas further down the line. Multi-signal and multi-hormone systems are being explored to use additional signals such as heart rate or motion sensing, and additional hormones such as amylin. We believe the technology will be evolving in these directions. Kovachev and collaborators are already sounding out the use of other hormones within the artificial pancreas. His team is also investigating whether the system might only need to be worn at certain times of the day, for instance, at night and/or after meals. The artificial pancreas looks likely to go from strength to strength. In conjunction with the other technologies currently being investigated, diabetes will soon be beating a hasty retreat. Recently covered research into the possibility of transplanting insulin-secreting cells into diabetic patients.